So interesting. Let's see if that holds for the other one. Down here with my other equation, if I have my 3/2 plus my 2/3, then I'm getting 13/6. 2 times 3, 6. So I'll have to check to make sure that holds in a minute. Make sure that's accurate. It keeps doing that. Now, let's see here. So here, with this one, if I measure the equivalent fraction in sixths instead of halves, I get 3. And I measure that one in sixths, I get 2. So it almost looks like whatever number here, I could do a C times B plus a A times D. Okay? Now the question is, does this always work? And so we need to test that by doing some more measurements, and that's where we get our rulers out. Let's grab a new piece of paper so that we can do a new line, like so. Now let's pick something that's not quite as easy. Let's do thirds and quarters. Do I want quarters or fifths? I don't think I have a 15s, so let's do quarters and thirds. So I'm going to go 3/4 and 2/3. So this is 3/4 and this is 2/3 there. And then quarters and thirds. That does not line up with my sixths. Oh, it does line up with my 12ths. So I find that that is equal to 17/12. And then if I measure that in twelfths, this is 9/12. And this is 8/12. So if I draw that out, I get my 3/4 plus 2/3 is equal to 17/12 up there. 4 times 3 is 12. So 4 times 2 is, see, 4 times 2, that's going to be 8. 8/12. 3 times 3 is 9. 9/12. And that does equal 17/12. As 9 and 8 is going to be 17. So that pattern does hold. So we've discovered this pattern. And we can write it like this, or we can write it like my C over A plus my D over B is equal to my C times B over A times B plus my A times D over A times B. And that, I can also write that using this form where I combine find the lower terms, and then all I have to do is add up the upper terms to get my answer. So this is a principle. This here is a principle of addition using fractions. This is how we add fractions. And this is the algebraic identity that matches that observation. And we discovered that by making rulers and measuring our lines for distance.